Hello everyone. This problem has been asked in GATE 2015 session 1 and it is of 2 marks. And this problem is numerical answer type, and if you see the problem, this problem is related to the analog and digital circuit subject. So the problem says that the figure shows a digital circuit constructed using negative age triggered JK flip-flops, assuming a starting state of Q2, Q1, Q0 is equal to 0, 0, 0. This state Q2, Q1, Q0, 0, 0 will be repeat number uh, after the number of cycles of the clock CLK. So if you want to have a detailed concept behind this problem, you kindly refer this NPTEL lecture number 63, JK flip-flop. The NPTEL name is Basic Electronics by Professor Mahesh Patil, Department of Electrical Engineering, IIT Bombay. And the YouTube link is also shown over here. So before we begin to solve this problem, let us have a quick recap about the JK flip-flop so that we can easily solve the problem. So the JK flip-flop, all know that in the SR flip-flop, when both the inputs S and R 1, then the output of the flip-flop is in indeterminate condition. So that is the problem with SR flip-flop. So this issue can be easily resolved by using the JK flip-flop. Similar to the SR flip-flop, the JK flip-flop has two inputs, and using the two inputs, the flip-flop can be set, reset, hold, or toggled. So unlike the SR flip-flop, in the JK flip-flop, we can see that when both inputs J and K are 1, then the output of the flip-flop toggles. The symbol of age triggered JK flip-flop and its truth table is shown over here. So the symbol of JK flip-flop is this one, and if you see the truth table of JK flip-flop, we can see that when both inputs are 0, 0, then the output we will get is that is hold condition or memory. Previous state. You can say the previous state. And when J input is 0 and K input is 1, then this is reset condition. And when J equal to 1, K equal to 0, then you will get set condition. And when both inputs are 1 and 1, then you will get the output toggle condition. That is the problem with SR flip-flop, where when both inputs are 1 1, then you will get indeterminate condition, while in the JK flip-flop, when both inputs are 1 and 1, you will get the toggle condition. You have to toggle the previous state. Now let us solve the problem. So here this circuit is shown over here. So first let us name the flip-flop. So starting from the left side, we name it as flip-flop 1, and this is flip-flop 2, this is flip-flop 3. So let the flip-flops be named as 1, be named as flip-flop 1, flip-flop 2, and flip-flop 3 from the left side. So we can see that here flip flop 2 and flip flop 3 are synchronized, synchronously clocked, synchronously clocked by Q0, which is clock divided by 2. So let us make the table for the flip flop 2 and flip flop 3. So if the first take it as the clock cycle, and then we take the flip flop inputs. So flip flop inputs for the flip flop 2 will be J2 and here K2 and again this is J1 for flip flop 1 K1. So these are flip flop inputs. So now we will see the connection. So J2 is connected with, so J2 will be equal to Q1. J2 is connected with Q1, K2 is connected with 1, it is always at 1 condition, and J1 is connected with Q2 bar, and K1 is always 1. Now make the output of flip flops. So output is Q2 and Q1, Q2 and Q1. Q1 is output for flip flop 2 and Q2 is output for flip flop 3. So in the initial condition, that is no clock pulse is given. What are the values for all these? So Q2 and Q1 both are 0. So now we will update this flip flop inputs. J2 is Q1, this is 0. K2 is always 1, 1. And J1 is Q2 bar, that is 1. And K1 is 1. Now these are the flip flop inputs. When we give the first clock pulse, then what should be the output we will get? So if J2 and K2 is 0, 1, that means it is in reset condition. So Q2 will come as 0. And when J and K are both 1, then you will get the toggle condition. So the previous state is 0, so the next state will be toggle, that means 1. Now we will update the flip-flop inputs. Flip-flop inputs will be Q1 is J2 is equal to Q1, Q1 is 1, K2 is always 1, J1 is equal to Q2 bar, Q2 bar is 0, Q2 is 0, so Q2 bar will be 1, K1 is equal to 1. Now when we give the second clock pulse, so what will be the output? So we can see that both the flip-flop have inputs as 1. Both flip-flop has input as 1, so that means it will toggle. Both flip-flop will be toggled. So the previous state for flip-flop 2, that is flip-flop 3, Q2 is 0, so it will be updated to 1. And this output for this flip-flop 2, then it will toggle to 0. Now we will update the flip-flop inputs. So the flip-flop inputs will be J2 is equal to Q1, it is 0, K2 is always 1, J1 is equal to Q2 bar, that is 0, and K1 is always 1. Now we will now when we will give the third clock pulse, we can see that both the both the flip-flops has input like 0 1. So 0 1, what it denotes? If J is 0 and K is 1, that denotes that it goes to reset condition. So you will get both the flip-flop outputs as 0 0. When both flip-flop output as 0 0, then similar to the initial condition, you will get the input size flip-flop input size 0 1 and 1 1. So this is the we made the table. So you have to remember that the clock cycles for flip-flop 2 and 3 is same, but the it is divided by whatever the clock cycle for flip-flop 1, it is divided by 2. So therefore you can write therefore after 3 clock cycles of 3 clock cycles of CLK divided by 2 Q2 Q1 is attaining 0 0 again, means like for clock cycle for flip-flop 1 is CLK and clock cycle will become for this flip-flop 2, that is CLK by 2, and flip-flop 3 CLK by 2. Both are synchronized, flip-flop 2 and flip-flop 3. So now it is given that we make the flip clock pulses. It is given that negative is triggered flip-flops. Negative is triggered JK flip-flops. So CLK will be so CLK will be so negative. So this is first clock pulse. Negative is triggered. This is second clock pulse. This is third clock pulse. This is fourth clock pulse. This is fifth clock pulse. This is sixth clock pulse, and so on. So CLK divided by 2 will be so for it the clock pulse will be CLK divided 2, so it will be this one. So for it negative is triggered, so here it is Q2 Q1. At the first clock pulse you will get 0 1. At the second clock pulse you will get Q2 Q1 as 1 0, and at the third clock pulse you will get again Q2 Q1 as 0 0. So we can see that for the flip flop 2 and flip flop 3, when we are getting the output Q2 and Q1 0 0, it is at the sixth clock cycle for flip flop 1. So that means, and one thing also you note that this for flip flop 1, both the inputs are 1 1. So it is always in toggle condition. So the Q0 is always 0. So we are getting for at this sixth clock pulse Q2, Q1, Q0 as 0 0. So you can write one point. So after the sixth clock cycle of CLK, Q2, Q1, Q0. Q0 is always 0. So you have to take care of Q2, Q1. Therefore, the number of cycles of clock is 6. 6 is the correct answer. So the correct answer is 6. That's all. Thank you.